Bismillahirrahmanirrahim. Assalamualaikum. How are you, everybody? Okay, we will continue our class in this another subtopic, which is bridges in local area network. So bridges is related to MAC frame handling. MAC layer receive data from LLC layer fields. MAC layer receive data from LLC layer. Okay, then the fields of the frame, MAC frame. So we have seen the MAC frame just now, the figure. It contains MAC control, MAC destination address, MAC source address, LLC and CRC. MAC layer detects error and discards frame. LLC optionally retransmits unsuccessful frame. So for unsuccessful frame, maybe LLC can retransmit the frame again. IEEE Project 802 has created a sublayer called Media Access Control that defines the specific access method for each LAN. So we have seen that different types of LAN topology has different types of MAC control. In contrast to LLC sublayer, the MAC sublayer contains a number of distinct modules. Each define the access method and the framing format specific to the corresponding LAN protocol. So bridges interconnects another LAN to N to 1. Interconnect other LANs and also interconnect LANs to 1. So that is the function of bridges. So two general approach possible in bridges. First is router, second is bridge. Bridge simpler and used to connect two similar lines. Meaning it involves minimal processing time because device use the same protocol. That is the bridges. Reason to use bridges. First is due to reliability, second is due to performance, third is due to security, and fourth is due to geography reasons. Reliability. By using bridges, the network can be partitioned into self-contained units. Therefore, it can provide fault isolation. In terms of performance, a number of smaller LANs will often give improved performance if devices can be clustered so that intra-network traffic significantly exceeds inter-network traffic. In terms of security, the establishment of multiple LANs may improve security of communications, keeping different types of traffic with different security needs on physically separate media. In terms of geography, clearly two separate LANs are needed to support devices clustered into geographically distant location. So if we have two separate location, then clearly it needs two separate LANs, and these LAN need to be connected using bridges. So bridge function. So this is the example of the internetworking of the LAN using bridges. Okay, so we have here LAN A and LAN B. So LAN A, it has 1 station, 2 station until station 10. For LAN B, it also have 1 station, 2 station until station 20. So this LAN A and LAN B is connected using bridge. Frames with address 11 through 20 are accepted and repeated at LAN B. Frames with address 1 through 10 are accepted and repeated on LAN A. So from these computers, any frames with address 1 to 10 will go through the bridge to LAN A, while the frame from LAN A with address from 11 to 20 will go through bridge and go to LAN B. Okay, bridge function. Read all frames transmitted on A and accept those addressed to any station on B. So all frames from A will go through the bridge to LAN B. Using the medium access control protocol for B, retransmit each frame on B. So it will do the same for B to A traffic. Okay. Bridge design aspect. No modification to frame content or format. No encapsulation of extra bit or header. Exact bitwise copy of frame. Minimal buffering to meet peak demand. Contains routing and address intelligence. May connect more than 2 LANs. So bridge can be used to connect more than 2 local area networks. Bridging is transparent to station. So these are the most common aspect in design of the bridge. Bridge protocol architecture. Bridge protocol architecture use IEEE 802.1d. Function at MAC level. Bridge does not need LLC layer. Can pass frame over external communication system. So can capture frame, encapsulate it, forward it across link, remove encapsulation and forward over LAN link. For example, wide area network link 1. Connection of the 2 LANs. Okay, so this is the LAN A and LAN B. 2 LANs connected by a single bridge. LANs employ the same MAC and LLC protocol. MAC frame whose destination is not on the immediate LAN is captured by the bridge, buffered briefly and then transmitted on the other LAN. As far as the LLC layer is concerned, there is a dialogue between peer LLC entities in the 2 endpoint station. The bridge need not contain an LLC layer because it is merely serving to relay the MMC frames. Okay, so here there are layers for LAN A and this is the same layers for LAN B. Figure show the way in which data are encapsulated using a bridge. Data are provided by some user to LLC. The LLC entity appends or add a header and passes the resulting data unit to the MAC entity, which appends a header and a trailer to form a MAC frame. So this is MAC frame. Okay, user data and this the LLC which append the LLC frame. LLC header appends a header. LLC entity appends a header here, and then MAC entity append the header, MAC header, and also append MAC trailer. On the basis of the destination MAC address in the frame, it is captured by the bridge. The bridge does not strip off the MAC field. Its function is to relay the MAC frame intact to the destination LAN. Thus, the frame is deposited on the destination LAN and captured by destination station. Bridges and LANs with alternative routes. So here is example for bridges and LAN. So you have LAN A, LAN B, LAN D, LAN E, LAN F, LAN G, and C. So you have so many LANs. So because of there are so many LANs, then there are also alternative routes. So the data can go through several routes from LAN A, LAN B to LAN to the from the station source to the destination. Station 1 transmit frame on LAN A to station 6. Frame will be read by bridge 102, 101, 102 and 107. For each bridge, the address station is not on a LAN to which the bridge is attached. Therefore, each bridge must make a decision whether or not to retransmit the frame on its other LAN in order to move it closer to its intended destination. In this case, bridge 102 should repeat the frame on LAN C, where bridge 101 and 107 should refrain from retransmitting the frame. So that is what happens when there are multiple routes, okay, for transmission of the frames. Once the frame has been transmitted on LAN C, it will be picked up by both bridges 105 and 106. Each must decide whether or not to forward the frame. In this case, bridge 105 should retransmit the frame on LAN F, where it will be received by station 6. So the station 6 is the destination. So why we need routing? The routing decision may not always be a simple one. Figure 1510 figure shows that there are two routes between LAN A and LAN E. Such redundancy provides for higher overall internet availability and creates the possibility for load balancing. In this case, if situation 1 transmit a frame on LAN A intended for station 5 on LAN E, then either bridge 101 or bridge 107 could forward the frame. It would appear preferable for bridge 107 to forward the frame, since it will involve only one hop, whereas if the frame travels through bridge 101, it must go through two hops, two loops. Another consideration is that there may be changes in the configuration. Okay, next is the fixed routing. Complex large LANs need alternative routes. Okay, so as shown in the example, the figure just now, we can consider that as one complex LAN. So if we have complex connection between LANs, we need to provide alternative routes. Bridge must decide whether to forward the frame. Bridge must decide LAN to forward frame to. Can use fixed routing for each source destination pair of LANs. Done in configuration. So fixed routing is normally has been done or prepared in the configuration. Usually least hop route, using a least the least number of route. Only change when topology changes. Widely used but limited flexibility. Okay, next is introduction and purpose of STP, spanning tree protocol. Spanning tree protocol is a layer 2 protocol, 802.1d. It runs on bridges and switches. Main purpose of STP is to make sure to not creating loops when you have redundant path. Loops are deadly to a network. So this STP is important when you have a redundant path, so that the frame does not move in a loop, because loop can be fatal, can be very dangerous. to a network. Ethernet bridge or switches must forward many known or unknown frames like ARP and DHCP to all physical parts, so it needs a loop-free topology. And Ethernet network with loop. So if like this, then this is considered network with loops. Spanning tree protocol, STP. Shortest path is based on cumulative link cost. Link costs are based on the speed of the link. The spanning tree protocol establishes a root node called the root bridges. The spanning tree protocol constructs a topology that has one path for reaching every network node. The resulting tree originates from the root bridges. Redundant links are not part of the shortest path. Trees are blocked. Redundant link, they are not part of the shortest path. Redundant link which not the shortest path are blocked. So these are the way we make the spanning tree protocol. You can read this on your own. Spanning tree protocol. BPDU contain enough information so that all switches can do the following: select a single switch, calculate the shortest path, designate one of the switches as the closest one to the root. Okay, can read this. Two key concepts, BID and path cost. STP execute an algorithm called spanning tree algorithm, STA. STA chooses a reference point called a root bridges and then determine the available path to the reference point. If more than two paths exist, STA picks the best path and block the rest. Okay. STP calculation make extensive use of two key concepts in creating loop-free topology, which is bridge ID and path cost. Bridge ID, BID. Bridge ID is used to identify each bridge. The bridge ID is used to determine the center of the network in respect to STP, known as the root bridge. Consists of two components, a 2-type bridge priority and a 6-byte MAC address. So BID consists of two components, a 2-byte bridge priority and 6-byte MAC address. So bridge priority and MAC address. So this is the 8 bytes BID, which consists of 2 bytes bridge priority and 6-byte MAC address. Bridge ID. Okay, so that's all. So bridge ID, bridge priority is usually expressed in decimal format and the MAC address in the BID is usually expressed in hexadecimal format. BID is used to elect a root bridge. Lowest bridge ID is the root. If all devices have the same priority, the bridge with the lowest MAC address becomes the root. Okay, so that's all for this part. We will discuss another part on the next video. Until then, hope you can you understand part of this lecture. Until we meet again in the next video. Thank you very much. Bye bye.